This can be a quick video acknowledging the genius of past mathematicians. I marvel at this every time I look at it, and the brain that figured this out. So we're going to take a look at the antiderivative of secant. We could have done cosecant as well. We're going to do secant in this case. So we might even throw in the cosecant because it goes pretty quickly. So this is the question. What is the antiderivative of secant theta d theta, or secant x dx, whatever we want to do? We'll go ahead and use thetas in this. And looking at that to begin with, there doesn't appear to be anything I could really make a u substitution for. It would create issues along the way. Maybe that's how somebody tried it in the beginning, was to say that u was going to be secant theta, but I don't know how that necessarily gets you any place. So what somebody came up with along the way was that this is a place where you can apply stupid math trick number 27. Stupid math trick number 27 is multiply by 1. We're just going to have to be real clever about that 1 that we multiply by. And they said multiply by 1 in this form: secant theta plus tangent theta over secant theta plus tangent theta. Okay? Both have same domain, so within the domain of everything here, this what's in red will always cancel to be a 1. Okay? And we've still got the d theta hanging out on the end there. So if we do some distributing of this secant, it will look like secant squared theta plus secant theta tangent theta over secant theta plus tangent theta d theta. And secant squared, I recognize that as being the derivative of the tangent, and secant theta tangent theta, that's the derivative of secant, and those are added together, and those are exactly the things that I have added together in the denominator. So if I made a u substitution and said u is secant theta plus tangent theta, then du would be the derivative of secant, which is secant theta tangent theta, plus the derivative of tangent, which is secant squared theta d theta, and that is exactly what I have going on up here. So this whole problem becomes the antiderivative of 1 over u du, which I know is the natural log of the absolute value of u plus a constant, but we don't like u. U is the natural log, the absolute value of secant theta plus tangent theta plus a constant. So this is the antiderivative of secant theta. See what it looks like for cosecant theta, just for the fun of it. So let's see, to start with blue here. Antiderivative of cosecant x dx. I'll go to x's this time. So my stupid math trick this time is going to be to multiply by, well, let's see what we get. Let's go with cosecant x plus cotangent x over cosecant x plus cotangent x, and we've still got the dx on this, and when we rewrite and distribute, we're going to have a cosecant squared x plus cotangent squared x over cosecant x plus cotangent x dx. And following the pattern from before and recognizing what's going on here, I'm going to say u is cosecant x plus cotangent x, which makes du negative cosecant x cotangent x minus cosecant squared x dx. So the opposite of du is cosecant x cotangent x plus cosecant squared x dx, which is exactly, well, it's exactly the negative of this. So my problem becomes negative antiderivative of now 1 over u du, which is negative natural log absolute value of u, which will be negative natural log absolute value of cosecant x plus cotangent x plus a constant, and there is the antiderivative of cosecant. Pretty cool stuff.